Hello everyone, in this short tutorial we're going to see how we can use RobustiPy in Google Colab. So this will allow you to use and to test RobustiPy without having to install Python directly in your computer, which is something that we understand is not that common. So what we have here in the screen is, in the left side we have the RobustiPy GitHub directory. And we're going to go to the simulated examples, and we're going to click in the Sim1 vanilla, which is the simple example that we have. As you can see, it's plain Python code. So we're going to do our best in this tutorial to actually just copy all of this into a Google Colab here. So in the right hand side, what we have is a screen with a Google Colab notebook. For those who are unfamiliar, Google Colab notebooks are basically Jupyter notebooks in the cloud, and they allow us to have Python code without having to install the Python interpreter in our computer. As you can see here, I have only run one line of code, which is the installation of the library. In this case, it's directly from GitHub. And it did finish correctly. But Google Colab will ask you to restart the session in order to have the package read by the session. So I just went ahead and did that before this video to not waste time in that step. So we can actually now hide that output there. So what we're going to do now is to add a new block of code and just copy line by line the code that we want to run. In this case, we are doing something very simple. We're just importing the libraries that we are going to use. So NumPy, Pandas, and RobustiPy. In this case, from RobustiPy, we are only using the OLS Robust class. So, and if we click Run, we will see that it finished correctly. In a new block of code, we will just copy pieces of our code here in the simulation function, because we don't want this to wrap up in a single function. We want to do it step by step. So let's copy these first 4 lines, and we are going to do a little quick reformatting here. So in this case, the only thing that we are doing is basically generating some random data. There is nothing really important in these lines. So we're just going to run it, and it should run correctly. We're going to add another piece of block code. Just close that. And we're going to paste it here. We're going to make sure to reformat this accordingly, as well as this one. And we're going to run it. And also it should work normally. So now we should have actually a data frame called df with synthetic or simulated data, and we can actually take a look at it. So we do Shift Enter to run it directly from our keyboard, and we can see here that we have our synthetic data set with 100 observations and 5 columns or 5 variables. And we have our main predictor and a bunch of covariates here. So now that we have our main predictor and the covariates, we need to generate our target variable. So we're going to take this piece of code to actually generate in the same data frame our target variable. And we're going to add it here. Again, we're going to do some quick formatting here. And we're going to click Run. And now, if we check our data frame again, we're going to see that we have a new column now. We have 6 columns, and we have our Y here as our target variable. All of these pieces of code here make sure that the synthetic target variable and the covariates are actually related to each other. Basically, they are based in one single covariance matrix. If I am correctly, I think should be this one. or some of these ones. So now we're going to actually be making use of our RobustiPy OLS robust library. So let's copy the pieces of code that we need, paste it, we do some quick reformatting, and we can review here what is going on. So our OLS robust class will deliver an object, and from that object we can call as well the method fit. Here we have as a y, we have our y, as the main predictor x, we have our x, and we have to specify the data as well. And here in the fit method we can specify which are the controls. So here we see that we are specifying this set. So I'm going to review what is there here, and we can see that set is a list of the names of the covariates that we want to include. You could in theory include all of these as your control, all of this list, but the code looks cleaner if you do this. This is just like aesthetic preferences. You can also specify the draws that you want to get, the false that you want to get for the out of sample statistics, and a seed for reproducible results. This will fix the seed inside the internal calculations of RobustiPy. And now we can just click run. This will take about a minute. Here we can see that RobustiPy gives you some information about what's going on here. So basically it repeats to you what are the parameters that you specified, what is it doing. Basically we are using pseudo-random R-squared metric for the out-of-sample metric. It tells you what is the estimate of interest, so the main predictor, and the total amount of models that it will run. In this case, 16,000 models. Almost done, and it's done. We have some warning here. Related to some calculations. In this case, we shouldn't worry too much about it. It's probably because our simulated data is not of the best quality. But for the purpose of this example, it should be alright. So we're going to add a next block of code. And we're going to try to get now the results from our calculations. Copy, paste, and we can click run. This by itself will do much. In order to get things from the result, we're going to have to call methods inside the result object. So for example, let's call a method to plot the results. So in the example that you have inside the repository, we specified a project name and some path for the figures. In Google Colab, we don't need that. Also, we don't need the extension to which we want to actually plot the figures. So we can just say that. We do want also, though, we want which specification we want to see. In this case, we are specifying by the index of the list. In this case, we are going to see specifications C2 and C3, basically. The size of the figure, the confidence interval size, and which information criteria we want to see. So if we click run, it's going to take a minute to plot, but it will give you our plot. Now, if we want to get a text summary of what is going on here, we can copy the last line, in our function and get the model summary by text, which should be more or less the same information that you will get from the plots. And that's all for this video. Thank you very much.